Okay, in this video we'll look at how to construct the product of z1 z2 in the complex plane. So uh, to find z1 z2 you could use De Moivre's theorem, that is the analytical way of obtaining the product of two complex numbers. But the same thing can be done in the complex plane. You just have to do some constructions, and geometry will actually give you the answer. So for most cases, you know that geometry comes in hand. So in the time where calculators did not exist, geometry came very in handy. So we'll look at how it is done. In order to do this construction, we will implement properties of triangles, similar triangles. Right, this is the construction we do. But first of all, you should know that the modulus of the product is given as the product between the lengths. So first I'll take c1 at this point with an argument θ1 and r1 being the modulus, and z2 with a modulus of r2 and θ1 angle. So this angle it makes with the real axis. Right, so when these 2 points are obtained in the complex plane, you can move on further with the product. So before that, we'll refresh our mind using the De Moivre's theorem. You know that you obtain the modulus of the product of two complex numbers to be the product of the two lengths, and the argument was the addition of the two angles. Right, so first we'll start from here. This is a clue, which means the c1 z2 product should be on a line which is inclined to the real axis by θ1 plus θ2. So how do you make θ1 plus θ2? You can see here that this angle is already θ2 and this is θ1. So I'm gonna draw a straight line which is by rotating this line θ1, by rotating this line at θ1, so I can obtain a straight line. So any point on this straight line will have an argument of z1 plus z2. So we cannot have any complex number, we just have to find a complex number whose length is equal to r1 times r2. So this is the construction we're going to do here. I'm gonna find a point which is of unit length. The unity on the real axis is the real axis. I'm going to find the point 1, 0. Right, this is the point to 1. I'm going to make this construction. Right, I'm going to make this construction, and then what I'm going to do is I'm going to copy this angle of this triangle. You can see there's an oblique triangle here. I'm going to copy this angle here, copy this angle here. Right, when I do that, I can draw a straight line, and the point it intersects with this line would be the point of the product. Let's call this P of z1. So we can write it as P of z2 and P of z1. So make sure you know the construction very well. So first you join the lines between point of c1 and real number 1 on the real axis. Then you measure the angle between the real line and these two lines, so interior angle here. Then you copy this angle here and paste it here, copy and paste here. So when you make this construction here, then this line will be intersected by this line. So this point is the point that represents the product of z1 and z2. You can see here that this point will have an argument θ1 plus θ2. Now we have to prove that the length here, length OP, this length OP is equal to r1 and r2, r1 times r2. So how do you go about doing it? We'll use the properties of triangles. So you can see here, let me put some numbers, not numbers, letters here. So we say A, and that's enough, right? So we call it P, this is P2 and P1. So you can see here that this angle, these two angles are similar in this. Okay, let me write it. OP2 P triangle and OA P1 triangle. So we're gonna compare these two triangles. You can see here these two angles, this angle and this angle are similar. What about this angle? This here is theta 1, and also this angle is theta 1. So these two angles are also similar. Now obviously you know that if two angles are similar, then the other angle will also be similar. So these two are similar triangles. If these two triangles are similar, you know that the ratio between the sides are also equal. So let me find the ratios. First I'll say OA divided by OP2. OA divided by OP2 should be equal to AP1 divided by P2P. P2P is equal to OP1 divided by OP. Right? For similar triangles, you know that this relationship is satisfied. So let me put some values here. OA is 1. OA length is 1. So we select it. Divided by OP2. OP2 is R2. Then AP1. AP1 we don't know. We don't know these two lengths. What about OP1? OP1 is R1. OP is the modulus of Z1, Z2. Now using this relationship, you can see that Z1, Z2, R1 into R2, right? Which means this point P represent the complex number, which is the product of Z1 and Z2. Okay, we can do the same treatment for division. I suggest you to do it as a homework.